Hi everyone, my name is Hamza. You also know me as Zed from Reach Discord server. I am here to present me and my teammate Satoshi's submission to Reach Bounty Hack. Our project is called Pokéchain, where a Pokemon Red game is played by inputs coming from the Algorand blockchain. First, I will be talking about how the game is designed and how the backend is implemented, and then we will be going through the code itself, and for the last part I will be demonstrating how the game actually works in practice. So our app has 3 steps. The last part is where the game is played. We have a Python bot that listens to API, which also listens to a smart contract. In smart contract, players decide their moves, and whenever consensus agrees on that move, it is passed the API and directed to Python bot, which plays the Pokemon game from an emulator. So, the logic behind our contract is fairly simple. At start, creator sets the game and sets a price for each move played, and there's a while loop, and there's a fork statement to see which class is taking action. If it's a creator, we give them a choice to end the game so that the game won't be infinitely running. And if it's a player, we let them choose their move, and whenever they choose a move, they pay the price for that. In code, we have this part, which is the backend. As you can see, creator sets a price at start, and as long as creator wants it to keep going, players can make a move and then pay the price to creator of the game. We also have a front end written in React. If you follow the tutorial in Reach site, you may be familiar with the code itself, because it looks pretty familiar to RPS React code. In this part, we send the move to API so that our Poképi bot can observe the move and play it. So there's also our views, and there's also the API that does the directing, but I won't be talking about these. They're not so much of a big deal. Now it is time for demonstration. I will be showing how the game actually works in practice. For that, I set up my React server in the background so that we won't lose any time. I also set up my Python bot to play the moves. I also set my GB emulator so we can see the moves translate into the game. I also have 3 separate windows for 1 creator and 2 players. It is a devnet, so I will be funding my accounts in the start. As a creator, we set the game to have 1 algo as price of a move, and we deploy the contract so that as players we can attach to the contract. Now we are ready, and as you can see, the creator has the choice to end the game. Various players have a little gamepad in front of them so that they can play the moves they want. Let's say as player 1, I wanted to go upwards to this grass section. I press up, I set the move. Normally there will be a prompt to confirm the transaction because I would be paying 1 algo for that move, but since this is a devnet, there won't be any. As you can see, the move got approved by the consensus, sent to an API, and the bot listening to API played the move. Let's try again with right input. I press right, and I also alternate to emulator because that's how Python bot works for the inputs. Normally I won't have to make this alternation because normally this emulator would be on a different machine. As you can see, it all translates into the game. Yeah. Let's skip a few steps so that we can fight in the game. Yeah, there's our first enemy. Alright. I want to show something else too. The moves don't have to be sequential. What I mean by that is, as player 2, I can input as many moves as I want. I don't have to wait for other players. So it is not like a turn-based game, but rather everyone sets the moves they want without a restriction. I press fight and I see the results. So let's say player 1 agrees on that move and plays A. We can see our first attack in the game. These steps are all similar, so I won't explain any. Now for the finishing blow, player 1 takes it. Oh no, let's say player 2 takes it then. With that being said, here's our first victory in the game. Let's play this part myself. As you can see, this was how Pokéchain works in practice. Thank you for watching and happy hacking, I guess.